Yo, Kipsters, welcome back to science class. Remember guys, choose science because everything else is dumb. No, I'm just kidding, but welcome back to science class. Our aim for today, Kipsters will be able to collect and record information to measure the mass of an object using a triple beam balance. Yesterday we used meter sticks to take up information. Today we're going to use a triple beam balance to look at mass. Take a look at the top right. It says mass. The amount of matter in an object measured in grams. And you can see that lowercase g. It gives us an example. A bowling ball compared to a beach ball is much heavier. Therefore, it has more mass. Before we get into the lesson, I have a kind of a tricky question for you guys, and I want you to think about it. Which weighs more? 50 kilograms of rocks or 50 kilograms of feathers? I want you to think about this silently to yourself for 20 seconds. Ready, go. Ten seconds left. Time's up. Kipsters, they are exactly the same. 50 kilograms of rocks is the exact same weight as 50 kilograms of feathers. Okay, let's jump into our lesson and learn a little bit more about mass. So what is mass? Mass is the amount of matter in an object. Pause this video and write down the definition of mass. Measuring mass. Mass is a property that can be measured using a triple beam balance. When we did our gallery walk of all the different lab tools, triple beam balance was one of our tools, and it told us that it helps us measure mass. Pause this video and write down the definition of mass. Measuring mass. The basic unit we measure mass is grams, or you could put G. When we want to measure large amounts of mass, like a human or a car, or even an elephant, this is measured in kilograms, kg. Small amounts of mass, like a paper clip or a piece of paper, is measured in milligrams, or mg. We're going to pause this video. All I want you to do is write down the units. They are in red. Now when we want to measure mass, we'll be using a triple beam balance to find the mass of different objects. And this is how we calculate the mass. First we're going to take the middle beam, we're going to add that to the last beam, then we're going to add that to the front bar. Let's practice. As you can see, the middle beam is 200. The last beam is 80. And the front bar is 7. If you add all of these up, you should end up with 287 grams. Example number 2. Go ahead and do this in your head. You have 10 seconds. Ten seconds are up. The middle number is 100. If we add that to the very back bar, that is 50. And if we add that to the very front bar, that is 4. Add those all up, we end up with 154 grams. Now, using a triple beam balance is not the most easy thing in the world. So these next steps are going to help you to figure out how exactly you use this in order to get accurate measurements. Let's check our slants. Make sure we're tracking the board. The first step in using a triple beam balance is to place all the beams on a level surface. So your tool needs to be on a flat desk or on the floor. Okay? It can't be on a book, it can't be on a binder, it needs to be on a flat surface. The second step, move the riders on the 3 beams to the left until they are at 0. Making such the riders fit down into the notches. The riders are those weights on the beams, just so you know. Make sure they're all the way to the left on top of the 0. Next step, place object that is to be measured in the center of the pan. Make sure you don't put it on the sides because you want to make sure it stays on just in case it starts to roll. Next step, Number 4. Carefully slide the largest rider to the right until the arm drops below the line. When this happens, gently move the rider back 1 notch. Repeat with the top weight. Slide the small weight until the lines match up. The sum of the riders is the mass of the object.